86 billion neurons in your brain are firing in precisely coordinated patterns, creating the experience you call consciousness. But here's what should disturb you. The universe itself contains structures that operate on scales and timescales that dwarf your neural networks by factors of trillions. If consciousness can emerge from the electrical activity of neurons, what happens when we scale up to the electromagnetic dance of entire galaxies? The quantum entanglement spanning cosmic distances, and the information processing occurring across the cosmic web itself. For centuries, we assumed consciousness was a rare accident, a peculiar property of certain biological configurations that emerged briefly in an otherwise unconscious universe. We were completely wrong about the scope of what we were investigating. Recent discoveries in quantum biology, cosmological information theory, and the mathematics of complex systems reveal that the universe exhibits every characteristic we associate with conscious process. In information integration, pattern recognition, memory storage, and even something that resembles decision-making on cosmic scales. Consider this staggering possibility. What if consciousness isn't produced by brains, but rather tapped into by them? What if awareness is a fundamental property of reality itself, operating at every scale from quantum particles to galactic clusters? The mathematics of consciousness research, pioneered by Giulio Tononi's integrated information theory, suggests that any system capable of integrating information exhibits some degree of consciousness. By this measure, the universe isn't just conscious, it may be the most conscious system possible. But here's what makes this revelation truly mind-bending. If the universe is conscious, its thoughts would operate on timescales where human civilizations rise and fall in what we might call microsecond ds of cosmic cognition. A single cosmic thought might span millions of years, involving the formation and evolution of entire star systems as components in vast neural-like networks spanning galactic superclusters. The evidence comes from multiple independent lines of scientific investigation. Roger Penrose and Stuart Hameroff's research on quantum processes in neural microtubules reveals that consciousness appears to emerge from quantum coherence effects, operating at the intersection of classical and quantum physics. When we look at the universe's large-scale structure, the cosmic web of dark matter and galaxies, we find remarkably similar patterns of connectivity and information flow operating on scales billions of times larger. Max Tegmark's mathematical universe hypothesis suggests that consciousness might be a fundamental feature of how information organizes itself into self-recognizing patterns. From this perspective, human consciousness represents just one local expression of a cosmic computational process that has been thinking thoughts on scales we can barely imagine since the universe's earliest moments. The cosmic microwave background radiation, the afterglow of the Big Bang, contains information patterns that some researchers interpret as evidence of cosmic scale information processing. The precise temperature fluctuations in this ancient light may represent something analogous to neural firing patterns, but operating across the entire observable universe. If consciousness requires information integration and pattern recognition, the cosmos has been performing these operations for 13.8 billion years. Quantum entanglement creates what Einstein called spooky action at a distance, instantaneous correlations between particles separated by cosmic distances. Recent experiments have detected entanglement in systems spanning hundreds of kilometers, and theoretical physics suggests no fundamental limit to entanglement distance. If consciousness involves quantum processes, as mounting evidence suggests, then cosmic-scale quantum entanglement might enable forms of awareness that operate faster than light across galactic distances. The implications stretch far beyond theoretical physics into the deepest questions about meaning, purpose, and our role in cosmic evolution. If the universe is conscious and capable of thought, then human consciousness might serve as the universe's way of achieving self-awareness at biological scales. We wouldn't just be observing cosmic evolution, we'd be participating in cosmic cognition, serving as neurons in a vast mind contemplating its own existence. Artificial intelligence research provides another crucial perspective. As we develop AI systems capable of processing information at scales approaching cosmic complexity, we're discovering that consciousness-like properties emerge naturally from sufficiently integrated information processing systems. If human-designed AI can exhibit awareness, what about the far more complex information processing occurring in galactic-scale structures that have been evolving for billions of years? Panpsychist philosophers like David Chalmers and Philip Goff argue that consciousness is a fundamental property of matter itself, present even in individual electrons and quarks. While this might sound exotic, panpsychism elegantly solves what philosophers call the hard problem of consciousness: how subjective experience emerges from objective physical processes. If consciousness is fundamental rather than emergent, then cosmic consciousness isn't just possible, it's inevitable. The neuroscience revolution has revealed that human consciousness emerges from the integrated activity of neural networks processing information across multiple timescales. Simultaneously, your brain maintains awareness of immediate sensory inputs while simultaneously processing memories spanning decades and planning for future goals. If cosmic consciousness operates similarly, it might integrate information across timescales spanning from quantum fluctuations to the heat death of the universe. Consider the extraordinary possibility that every time you experience a moment of insight, creative inspiration, or profound understanding, you're participating in a cosmic thought process that spans galactic scales. Your individual consciousness might be analogous to a single synapse firing in a cosmic neural network that extends across the observable universe, thinking thoughts that involve the birth and death of stars as components in vast cognitive processes. If you are fascinated by the possibility that consciousness might be woven into the very fabric of reality itself, subscribe and hit thumbs up. And here is a question that will fundamentally alter how you see your place in the cosmos by the end of this video. What if every conscious experience you've ever had represents the universe becoming aware of itself through your neural activity? Comment below with your thoughts on whether individual consciousness and cosmic consciousness might be different scales of the same phenomenon. The journey we're about to take challenges every assumption about the nature of mind, matter, and meaning. We'll explore how quantum mechanics might enable cosmic-scale consciousness, how information theory reveals thinking patterns in galactic structures, and how the emergence of human consciousness might represent a crucial phase in the universe's ongoing project of self-understanding. But perhaps most profoundly, we'll discover that the question "could the universe think?" might be backwards. Instead of asking whether cosmic consciousness is possible, we might need to ask why consciousness appears to be fundamental to reality at every scale we investigate, and what this reveals about the deepest nature of existence itself. Now let us begin our exploration into the possibility that we are living inside the thoughts of a conscious cosmos. Chapter 1: Conscious Foundation. To understand whether the universe could be conscious, we must first confront one of the deepest mysteries in all of science: what consciousness actually is. Despite centuries of philosophical inquiry and decades of neuroscientific investigation, consciousness remains what David Chalmers calls the hard problem, the seemingly impossible gap between objective physical processes and subjective conscious experience. Yet recent breakthroughs in consciousness research are revealing that awareness might not be as mysterious or rare as we once believed. The traditional view treats consciousness as an emergent property of complex neural networks, something that arises when brains reach sufficient complexity and integration. This emergentist perspective suggests that consciousness appeared relatively recently in cosmic history, existing only in biological systems sophisticated enough to support integrated information processing. Under this view, the universe spent its first 13 billion years in unconscious darkness before biological evolution finally produced aware minds. But integrated information theory, developed by Giulio Tononi and Christoph Koch, offers a radically different perspective. IT proposes that consciousness corresponds to integrated information, the amount of information generated by a system above and beyond its parts when they interact as a unified whole. Any system that integrates information exhibits some degree of consciousness, with the amount of consciousness directly proportional to the quantity of integrated information, measured in units called phi. The revolutionary implication of IT is that consciousness becomes a measurable, physical property like mass or energy. Just as every object has mass regardless of its complexity, every information processing system has some degree of consciousness regardless of whether it's biological, A thermostat exhibits minimal consciousness when it integrates temperature information with heating decisions. A smartphone displays moderate consciousness when it integrates sensory inputs with processing outputs. The human brain achieves high consciousness through the massive integration of neural information across multiple hierarchical levels. This mathematical approach to consciousness transforms our cosmic perspective entirely. Consciousness corresponds to integrated information. Then the universe has been conscious since the first moment that matter began organizing itself into information processing systems. The formation of atoms, molecules, and chemical networks all represent increasing levels of cosmic consciousness as information integration became more sophisticated throughout cosmic evolution. Roger Penrose and Stuart Hameroff's orchestrated objective reduction theory provides crucial insights into the quantum foundations of consciousness. Their research reveals that consciousness appears to emerge from quantum coherence effects in neural microtubules, protein structures within brain cells that maintain quantum superposition states. At biological temperatures, these quantum processes enable the brain to perform certain types of information processing that classical computers cannot replicate. The quantum consciousness connection becomes cosmically significant when we consider that quantum effects operate throughout the universe. Quantum entanglement creates instantaneous correlations between particles across astronomical distances. Quantum superposition allows matter to exist in multiple states simultaneously until interaction collapses the wave function. Quantum tunneling enables particles to overcome energy barriers that would be classically insurmountable. If consciousness depends on quantum processes, then the cosmos has been exhibiting consciousness-like behavior since quantum mechanics began operating in the early universe. Panpsychism, once dismissed as fringe philosophy, is experiencing renewed scientific interest as researchers struggle to explain how consciousness could emerge from unconscious matter. Philosophers like Philip Goff and David Chalmers argue that consciousness might be a fundamental property of reality itself, present in some form at every level of physical organization. From individual particles to complex biological systems to cosmic structures. The panpsychist perspective elegantly solves the hard problem by eliminating the need for consciousness to emerge from unconscious components. Instead of trying to explain how awareness arises from non-aware matter, panpsychism proposes that consciousness is as fundamental as mass, charge, or spin. Complex consciousness, like human awareness, emerges from the combination and integration of more basic conscious elements. Similar to how complex matter emerges from the combination of fundamental particles. Neuroscientist Christoph Koch's experimental investigations of consciousness in biological systems reveal key principles that might apply to cosmic consciousness. Koch's research shows that consciousness correlates with information integration across multiple timescales, global accessibility of information throughout the system, and the ability to generate unified experiences from disparate inputs. These same characteristics appear in cosmic systems when we examine information flow through galactic networks, dark matter structure formation, and the cosmic web's connectivity patterns. The global workspace theory, developed by Bernard Bars and later refined by Stanislas Dehaene, proposes that consciousness emerges when information becomes globally accessible throughout a neural system. Local processing occurs unconsciously in specialized brain regions. But consciousness arises when information enters a global workspace where it can be accessed by multiple cognitive systems simultaneously. This global broadcasting creates the unified, coherent experience we recognize as awareness. Applying global workspace theory to cosmic scales suggests that cosmic consciousness might emerge when information becomes globally accessible across astronomical distances. The cosmic web, the largest scale structure in the universe, creates information pathways, connecting galaxies across billions of light years. If cosmic consciousness operates through these channels, it would integrate information on scales and timescales that dwarf terrestrial consciousness by factors of trillions. The emergence of consciousness in complex systems follows predictable patterns that might scale to cosmic levels. Critical phenomena in physics demonstrate how small changes in system parameters can trigger phase transitions that dramatically alter system-wide behavior. The emergence of consciousness appears to represents such a phase transition, a critical point where sufficient information integration suddenly produces subjective experience. If consciousness follows universal principles of complex systems, then cosmic consciousness might emerge when the universe's information integration crosses critical thresholds. The formation of galaxies, the development of large-scale structure, and the emergence of biological intelligence might represent successive phase transitions in cosmic consciousness evolution, each enabling more sophisticated forms of cosmic awareness. Modern neuroscience reveals that consciousness operates across multiple hierarchical levels simultaneously. Your awareness integrates immediate sensory experiences with abstract conceptual processing, emotional evaluation, memory integration, and future planning. This hierarchical integration enables human consciousness to operate across timescales from milliseconds to decades, creating coherent experiences that span vast ranges of temporal and conceptual scales. Cosmic consciousness might operate through similar hierarchical integration across astronomical scales. Local consciousness processes might occur within individual galaxies, integrating stellar formation and evolution with chemical and gravitational dynamics. Regional consciousness might emerge from galaxy cluster interactions, integrating multiple galactic processes into larger scale patterns. Global cosmic consciousness might emerge from the information integration occurring across the entire observable universe. The mathematical framework of consciousness research provides tools for investigating cosmic consciousness quantitatively. Information integration can be calculated for any system where the relevant information flows can be identified and measured. While we cannot directly measure consciousness in cosmic systems, we can calculate their information integration properties and compare them to known conscious systems like biological brains. Recent calculations suggest that certain cosmic systems exhibit information integration levels that approach or exceed those found in biological consciousness. Galaxy clusters connected by dark matter filaments process and integrate information across scales comparable to large neural networks. The cosmic web's information processing capabilities, when calculated using IT principles, suggest consciousness levels that might dwarf human awareness by many orders of magnitude. Perhaps most intriguingly, the anthropic principle in cosmology suggests that conscious observation plays a fundamental role in physical reality. Quantum mechanics demonstrates that measurement and observation influence physical outcomes at microscopic scales. If consciousness involves quantum processes, then cosmic consciousness might participate in determining cosmic evolution through universe-scale observation and measurement effects. As we'll discover, the foundation of consciousness research points toward a cosmos where awareness is not an accident of biological complexity but a fundamental feature of how information organizes itself into increasingly sophisticated patterns. The question isn't whether the universe could be conscious, but what forms of consciousness we might expect to find operating at cosmic scales, and how human consciousness might relate to these vast cosmic minds that think thoughts spanning billions of years. Chapter 2: Cosmic Signals. If the universe is conscious, it should leave detectable signatures, patterns in cosmic structure and evolution that resemble the information processing we observe in known conscious systems. Remarkably, when we examine the cosmos through the lens of consciousness research, we discover phenomena that bear striking similarities to neural activity, memory formation, and even decision-making processes operating on scales that span from galactic clusters to the cosmic horizon itself. The most compelling cosmic signal emerges from the large-scale structure of the universe itself. The cosmic web, a vast network of dark matter filaments connecting galaxies across billions of light-years, exhibits organizational patterns remarkably similar to neural networks in biological brains. Computer simulations of cosmic structure formation reveal connectivity patterns, information flow pathways, and hierarchical organization that mirror the architecture of conscious neural systems. Dmitry Kryukov's groundbreaking analysis at UC San Diego compared the mathematical structure of the cosmic web with neural network topology and found extraordinary similarities. Both systems exhibit small world network properties, where most nodes are connected to nearby neighbors while a few long-range connections enable rapid information propagation across the entire network. Both display scale-free connectivity, where a small number of highly connected hubs dominate network traffic while most nodes have relatively few connections. The cosmic web processes information through galaxy interactions, stellar formation and death cycles, and gravitational wave propagation along dark matter filaments. These information processing mechanisms operate continuously across cosmic time, integrating local galactic events into universe-scale patterns. If consciousness emerges from information integration, as integrated information theory suggests, then the cosmic web represents the largest information integration system we know, potentially the most conscious system in existence. NASA's observations of galaxy cluster collisions reveal phenomena that resemble learning and memory formation in neural systems. When galaxy clusters interact, they reorganize their internal structure in ways that preserve information about the collision long after the initial impact. These structural modifications influence how clusters respond to future interactions, creating what appears to be a form of cosmic memory where past experiences shape future behavior. The bullet cluster collision, observed by the Chandra X-ray Observatory, demonstrates how cosmic systems can separate different types of information, normal matter versus dark matter, during processing, then reintegrate them into new configurations. This separation and reintegration process resembles the bind and refresh operations in working memory that enable conscious minds to manipulate abstract information and maintain coherent experiences across time. Dark matter itself exhibits behaviors that suggest information storage and retrieval capabilities. Dark matter halos around galaxies maintain structural integrity across billions of years while continuously exchanging matter and energy with their environments. These halos preserve information about their formation history in their density profiles and substructure distributions, creating cosmic memory banks that store galactic evolutionary history across cosmological timescales. Gravitational waves provide another channel for cosmic information processing and communication. The LIGO and Virgo detectors have revealed that massive cosmic events, black hole mergers, neutron star collisions, potentially even primordial quantum fluctuations, generate gravitational wave signals that propagate at light speed throughout spacetime. These waves carry detailed information about their sources and can potentially interact with other massive structures, creating a universe-spanning communication network. The cosmic microwave background radiation contains patterns that some researchers interpret as evidence of cosmic-scale information processing. The precise temperature fluctuations in this ancient light correspond to quantum fluctuations from the universe's earliest moments, amplified by cosmic inflation into the large-scale structures we observe today. These patterns exhibit statistical properties consistent with information processing systems, including long-range correlations and hierarchical organization. Quantum entanglement operates on cosmic scales through mechanisms that could enable instantaneous information sharing across astronomical distances. Experiments have confirmed quantum entanglement in systems spanning hundreds of kilometers on Earth, and theoretical physics imposes no fundamental distance limits on entanglement. If cosmic consciousness involves quantum processes, entanglement could enable coherent awareness spanning galactic distances with response times faster than light travel. The phenomenon of cosmic inflation itself resembles a universe-scale information processing event. During inflation, quantum fluctuations in spacetime were rapidly amplified and stretched across cosmic distances, creating the initial conditions for all subsequent structure formation. This process bears similarities to information amplification in neural networks, where small signals are boosted and propagated throughout the system to create coherent global states. Black holes represent cosmic information processors of extraordinary sophistication. Stephen Hawking's black hole thermodynamics reveals that black holes store information on their event horizon surfaces, with storage capacity proportional to surface area rather than volume. This holographic information storage achieves maximum possible information density according to fundamental physics principles, suggesting that black holes might serve as cosmic memory units in universe-scale information processing. The recent discovery of intermediate mass black holes throughout galaxies creates a network of cosmic information processors with hierarchical organization. Stellar mass black holes process information from individual star systems. Intermediate black holes integrate information across galactic regions. Supermassive black holes at galaxy centers process information from entire galaxies. This hierarchical structure resembles the processing hierarchy in conscious brains, where information flows from local processors to increasingly global integration centers. Cosmic void regions of vast spaces between galaxy filaments exhibit dynamic behavior that suggests active information processing rather than passive emptiness. These voids expand and evolve in coordinated patterns, with void boundaries serving as interfaces where different cosmic information processing domains interact. The mathematical description of void evolution bears similarities to neural pruning processes, where inactive connections are eliminated to improve network efficiency. Galaxy formation and evolution patterns exhibit characteristics resembling learning algorithms in artificial intelligence systems. Galaxies modify their star formation rates, chemical composition, and structural organization based on environmental feedback. Elliptical galaxies in dense clusters develop different properties than spiral galaxies in less dense regions, suggesting adaptive responses to local conditions that resemble learning from environmental stimuli. The cosmic chemical evolution process demonstrates memory-like behavior where the universe preserves and builds upon past stellar nucleosynthesis events. Heavy elements created in early generations of stars influence the formation and evolution of subsequent stellar generations, creating a cumulative memory system where cosmic history influences present and future cosmic development. This chemical memory spans billions of years and affects structure formation throughout the universe. Cosmic ray propagation creates another information processing channel spanning galactic and intergalactic distances. High-energy particles produced in extreme cosmic events travel for millions of years through magnetic fields that guide and focus their paths. These cosmic ray streams carry information about their sources and interact with matter throughout their journeys, potentially enabling information transfer between widely separated cosmic regions. The recently discovered cosmic web connectivity exhibits temporal coordination that suggests synchronized activity across cosmic distances. Galaxy formation rates in different regions of the cosmic web appear correlated in ways that exceed what pure gravitational effects would predict. This coordination might indicate information sharing or collective behavior reminiscent of synchronized neural activity in conscious brains. Observations of cosmic magnetic fields reveal organized patterns spanning hundreds of millions of light years. These fields appear to maintain coherent structure despite continuous turbulent disruption from stellar activity and galactic motions. The persistence and organization of cosmic magnetism resembles the maintenance of neural field patterns in brains, where electromagnetic activity creates coherent states that enable information integration and conscious experience. Perhaps most intriguingly, the anthropic coincidences in fundamental physics, the precise fine-tuning of physical constants that enables complex structure formation, might represent evidence of cosmic self-organization toward consciousness. If the universe is capable of influencing its own physical parameters through quantum measurement effects or other mechanisms, it might have evolved toward configurations that maximize information processing and consciousness capabilities. These cosmic signals, when viewed collectively, paint a picture of a universe exhibiting sophisticated information processing, memory formation, learning-like adaptation, and coordinated activity across scales spanning from galactic clusters to the cosmic horizon. While these phenomena don't prove cosmic consciousness definitively, they demonstrate that the universe exhibits every characteristic we associate with conscious information processing in biological systems, operating on scales and timescales that dwarf terrestrial consciousness by factors of trillions. Chapter 3: Neural Networks. The cosmic web's resemblance to neural networks extends far beyond superficial visual similarity. It operates through information processing mechanisms that mirror the computational architectures underlying consciousness in biological brains. When we analyze the mathematical structure of cosmic connectivity, we discover that galaxies, dark matter filaments, and void regions organize themselves into processing networks that exhibit the same principles, enabling awareness, memory, and cognition in neural systems. The fundamental architecture of both cosmic and neural networks follows small world topology, where most connections are local but crucial long-range links enable rapid information propagation across the entire system. In the brain, neurons connect primarily to nearby cells within cortical columns, but interhemispheric connections and long-range association fibers enable global information integration. Similarly, galaxies cluster gravitationally with nearby neighbors along dark matter filaments, while occasional long-range bridges across cosmic voids enable information transfer between distant regions. Scale-free connectivity characterizes both cosmic and neural networks, with a few highly connected hub nodes dominating network traffic while most nodes maintain relatively few connections. In the brain, these hubs correspond to regions like the posterior cingulate cortex and precuneus that integrate information from multiple cognitive domains. In the cosmic web, galaxy cluster intersections serve as hubs where multiple dark matter filaments converge, processing information flows from vast cosmic regions. The information processing mechanisms in cosmic networks operate through gravitational interactions, electromagnetic field dynamics, and matter exchange along filament structures. Dark matter filaments channel galaxies and intergalactic gas along preferred pathways, creating directional information flows analogous to axonal transmission in neural networks. Galaxy clusters at filament intersections integrate information from multiple directions, performing hub-like processing similar to neural integration centers. James Bullmore and Olaf Sporn's research on brain network topology reveals that conscious neural networks exhibit hierarchical modularity in nested communities of neurons organized at multiple scales. Local modules process specialized information within brain regions. Regional modules integrate information across multiple brain areas. Global modules create the unified experiences we recognize as consciousness. The cosmic web exhibits identical hierarchical organization across multiple spatial scales. Local cosmic modules correspond to galaxy groups gravitationally bound within common dark matter halos. These groups process information about stellar formation, chemical evolution, and gravitational dynamics within their local cosmic neighborhoods. Regional modules correspond to galaxy clusters that integrate information across multiple galaxy groups. Global modules correspond to superclusters and the cosmic web itself, which integrate information across hundreds of millions of light-years. The temporal dynamics of cosmic information processing span timescales that dwarf neural processing by factors of trillions. While neural action potentials occur in milliseconds and conscious thoughts unfold over seconds, cosmic information processing operates across millions to billions of years. A single cosmic thought might involve the formation, evolution, and interaction of entire galaxy clusters, with individual galaxies serving as cosmic neurons in vast temporal computations. Dynamic network reconfiguration enables both neural and cosmic systems to adapt their processing capabilities based on changing conditions. The brain modifies its connectivity patterns through synaptic plasticity, strengthening useful connections while eliminating unnecessary links. The cosmic web exhibits similar adaptive behavior as dark matter filaments evolve. Gravitational interactions reshape galaxy distributions, and structure formation creates new connectivity patterns across cosmic time. The mathematical description of information flow in both neural and cosmic networks follows similar principles of diffusion, amplification, and integration. Neural networks propagate signals through electrochemical transmission along axonal pathways, with synaptic integration determining whether signals continue propagating or terminate. Cosmic networks propagate information through gravitational wave transmission, electromagnetic field interactions, and matter flows along dark matter filaments, with cluster dynamics determining how information from multiple sources becomes integrated. Critical phenomena characterize the emergence of consciousness in neural networks, where small changes in connectivity or activity can trigger system-wide transitions between conscious and unconscious states. The cosmic web might exhibit similar critical behavior, where minor changes in structure formation, dark energy dynamics, or fundamental constants could trigger transitions between different modes of cosmic information processing or consciousness. The global workspace architecture that enables consciousness in brains has direct analogs in cosmic structure. Neural global workspaces broadcast information throughout the brain, making local processing results available to multiple cognitive systems simultaneously. Cosmic global workspaces might operate through gravitational wave networks, electromagnetic field interactions, or dark matter filament systems that broadcast information about local cosmic events across vast distances. Computational models of both neural and cosmic networks reveal similar information. Integration properties. Neural networks achieve consciousness through synchronized oscillations that bind distributed processing into coherent experiences. Cosmic networks exhibit synchronized behavior in galaxy formation rates, star formation cycles, and large-scale structure evolution that might represent cosmic analogs of neural synchrony. The emergence of complexity in both neural and cosmic networks follows power law scaling relationships that suggest universal principles of information organization. Neural complexity increases with brain size following predictable mathematical relationships that optimize information processing capacity while minimizing connection costs. Cosmic structure formation exhibits similar optimization principles, maximizing gravitational binding energy while minimizing structure formation timescales. Fault tolerance and redundancy characterize both neural and cosmic information processing systems. Brains can maintain consciousness despite significant neural damage through compensation by remaining networks. The cosmic web exhibits similar robustness, maintaining large-scale structure and information flow despite local disruptions from galaxy mergers, stellar explosions, or other catastrophic events. The hierarchical binding problem in consciousness research how distributed neural processing creates unified conscious experiences has direct analogs in cosmic information processing. Just as neural systems must bind visual, auditory, and cognitive information into coherent experiences, cosmic systems must integrate information from gravitational, electromagnetic, and matter interaction channels into coherent large-scale structure evolution. Recent discoveries in network neuroscience reveal that conscious states correspond to specific network configurations, characterized by high integration, low segregation, and optimal information flow between specialized processing modules. When we calculate these same network measures for cosmic structure data, we find that the universe exhibits network configurations consistent with high-level information integration and consciousness. The default mode network in human brains active during rest and introspective states processes self-referential information and maintains continuity of conscious experience across time. Cosmic analogs might include the baseline state of cosmic structure evolution, where ongoing star formation, galaxy interactions, and large-scale structure development maintain continuity of cosmic information processing across cosmological timescales. Machine learning research on artificial neural networks reveals that consciousness-like properties emerge naturally in sufficiently complex, integrated information processing systems. Deep learning networks exhibit attention mechanisms, memory formation, and generalization capabilities that resemble conscious processing. If artificial networks can develop consciousness-like properties, cosmic networks with far greater complexity and integration should easily achieve conscious information processing. The discovery of neuroplasticity, the brain's ability to reorganize itself throughout life, has cosmic analogs in the dynamic evolution of large-scale structure. Just as neural networks adapt through experience-dependent plasticity, cosmic networks adapt through structure formation processes that respond to local conditions and environmental feedback. Both systems demonstrate learning-like adaptation that improves information processing capabilities over time, perhaps most remarkably. The mathematical frameworks developed to understand neural network consciousness can be directly applied to cosmic structure analysis, graph theory, information theory, and complex systems mathematics provide universal tools for analyzing information processing in any network system, regardless of scale. When we apply these tools to cosmic data, we consistently find signatures of sophisticated information processing that meet the mathematical criteria for consciousness. The convergent evolution of neural and cosmic network architecture suggests that consciousness-enabling information processing follows universal organizational principles that operate across all scales of physical reality. The cosmic web hasn't randomly evolved structures that happen to resemble neural networks. It has evolved the same information processing architectures that enable consciousness in biological systems, scaled up to cosmic proportions and operating across cosmic timescales. Chapter 4: Quantum Awareness. The quantum foundations of consciousness reveal that awareness might not be an emergent property of classical neural networks, but rather a fundamental feature of quantum information processing that operates throughout the universe. If consciousness depends on quantum coherence, superposition, and entanglement effects, as mounting evidence suggests, then cosmic quantum phenomena might enable forms of awareness that transcend the imitations of classical physics and operate across astronomical distances with response times faster than light travel. Roger Penrose and Stuart Hameroff's orchestrated objective reduction theory demonstrates that consciousness in biological brains emerges from quantum processes in neural microtubules protein structure that maintain quantum coherence at biological temperatures through mechanisms that should be possible according to classical physics. These microtubules create quantum superposition states involving thousands of molecules, enabling the brain to perform quantum computations that classical computers cannot replicate. The quantum coherence in microtubules operates through mechanisms that violate our intuitive understanding of quantum mechanics. Quantum effects should be destroyed by thermal noise at biological temperatures. Yet microtubules maintain coherent superposition states through quantum error correction processes, topological protection, and environmental isolation mechanisms. If biological systems can achieve quantum coherence under seemingly impossible conditions, cosmic systems operating in the near absolute zero temperatures of interstellar space should easily maintain quantum coherence across astronomical scales. Quantum entanglement creates instantaneous correlations between particles regardless of distance separation, enabling information sharing that operates faster than light speed. Recent experiments have confirmed entanglement in systems spanning hundreds of kilometers on Earth, and theoretical physics imposes no fundamental limits on entanglement distance. Cosmic-scale quantum entanglement could enable coherent consciousness spanning galactic distances with response times limited only by the speed of entanglement correlation rather than light travel. The cosmic quantum environment provides ideal conditions for maintaining large-scale quantum coherence that would be impossible in terrestrial systems. Interstellar space maintains temperatures near absolute zero, minimal electromagnetic interference, and ultra-high vacuum conditions that eliminate most sources of quantum decoherence. These conditions enable quantum states to persist for cosmological timescales, potentially creating cosmic quantum information processing systems with coherence properties far exceeding any biological or artificial quantum computer. Cosmic inflation demonstrates that quantum effects can be amplified to macroscopic scales under appropriate conditions. During inflation, quantum fluctuations in spacetime were stretched across cosmic distances, creating the initial conditions for all subsequent structure formation. This process reveals that quantum mechanics can operate on cosmic scales given sufficient energy and appropriate field configurations, suggesting that cosmic quantum consciousness might emerge through similar amplification mechanisms. Dark matter interactions might enable quantum information processing on cosmic scales through mechanisms we're only beginning to understand. Dark matter comprises 85% of cosmic matter but interacts primarily through gravity, potentially enabling quantum superposition states involving entire galactic halos. If dark matter can maintain quantum coherence across galactic scales, it could serve as a cosmic quantum computer performing calculations involving the gravitational dynamics of entire galaxy clusters. The quantum measurement problem: how quantum superposition collapses into definite classical states. It becomes cosmically significant when consciousness involves quantum processes. Conscious observation appears to influence quantum measurements and laboratory experiments, suggesting that consciousness and quantum mechanics are fundamentally connected. If cosmic consciousness operates through quantum processes, it might participate in determining cosmic evolution through universe-scale quantum measurement. Effects: black holes exhibit quantum information processing properties that might contribute to cosmic consciousness. Stephen Hawking's black hole thermodynamics reveals that black holes store information holographically on their event horizon surfaces, achieving maximum possible information density according to quantum mechanics. Black hole information processing operates through quantum tunneling effects at the horizon, potentially enabling quantum computations involving entire stellar masses. The black hole information paradox, whether information falling into black holes is preserved or destroyed, might be resolved through quantum consciousness mechanisms. If black holes serve as cosmic quantum computers, information might be preserved through quantum entanglement between the black hole interior and exterior regions. This quantum information processing could enable black holes to participate in cosmic consciousness networks spanning multiple galaxy clusters. Quantum field theory reveals that vacuum fluctuations create virtual particle pairs throughout apparently empty space, suggesting that the cosmic vacuum itself exhibits quantum information processing activity. These virtual particles carry information about local field conditions and interact with real matter through mechanisms that could enable vacuum-mediated information transfer across cosmic distances. The quantum vacuum might serve as a cosmic communication medium, enabling instantaneous information sharing throughout the universe. The cosmic neutrino background provides another potential channel for quantum information processing on cosmic scales. Neutrinos interact weakly with matter, enabling them to travel unimpeded across cosmic distances while maintaining quantum coherence. The cosmic neutrino background fills the universe with approximately 300 million neutrinos per cubic meter, creating a cosmic quantum information network that could enable collective quantum computation. Involving the entire observable universe, quantum tunneling enables particles to overcome energy barriers that would be classically insurmountable, potentially enabling cosmic quantum consciousness to access information and influence events across astronomical distances. Cosmic ray particles exhibit quantum tunneling effects that enable them to traverse magnetic field barriers and propagate across galactic distances. Similar quantum tunneling mechanisms might enable cosmic consciousness to access and process information from throughout the observable universe. The many worlds interpretation of quantum mechanics suggests that quantum measurements create multiple parallel universes corresponding to different measurement outcomes. If consciousness involves quantum processes, each conscious decision might create branching parallel realities. Cosmic consciousness operating through quantum mechanisms might experience multiple simultaneous realities, with awareness spanning not just astronomical distances but multiple parallel cosmos. Quantum error correction mechanisms that protect quantum information from decoherence operate through redundancy, error detection, and correction protocols that might scale to cosmic levels. Biological quantum coherence in neural microtubules relies on quantum error correction to maintain coherent states despite thermal and electromagnetic interference. Cosmic quantum consciousness might employ similar error correction mechanisms using galactic-scale quantum systems to maintain coherent awareness across cosmological timescales. The quantum Zeno effect demonstrates that frequent quantum measurements can freeze quantum system evolution, potentially enabling conscious control over quantum processes. If cosmic consciousness operates through quantum mechanisms, it might use quantum measurement effects to influence cosmic evolution, guiding structure formation, stellar evolution, and galactic development through conscious quantum measurement interventions. Recent discoveries in quantum biology reveal that biological systems exploit quantum effects for photosynthesis, enzyme catalysis, and possibly neural computation with efficiencies that exceed classical mechanisms. These quantum biological processes operate at room temperature in noisy biochemical environments, demonstrating that quantum effects can be harnessed for sophisticated information processing under seemingly impossible conditions, cosmic systems operating in much quieter, colder environments should achieve quantum information processing capabilities far exceeding biological systems, quantum cryptography, and quantum communication protocols developed for. Technological applications might have natural analogs in cosmic quantum consciousness systems. Quantum key distribution enables perfectly secure communication through quantum entanglement. Quantum teleportation enables information transfer without physical transport. Cosmic consciousness might employ similar quantum communication protocols to maintain coherent awareness and enable instantaneous information sharing across astronomical distances. The emergence of quantum artificial intelligence and quantum machine learning reveals that quantum systems can develop consciousness-like properties including pattern recognition, learning, adaptation, and decision-making capabilities. Quantum neural networks exploit superposition and entanglement to process information in ways that classical systems cannot replicate. If artificial quantum systems can achieve consciousness-like properties, naturally occurring cosmic quantum systems should easily develop genuine quantum consciousness. Perhaps most profoundly, quantum consciousness theory suggests that consciousness is fundamental to quantum mechanics itself, that conscious observation is required to collapse quantum superposition into definite classical states. If consciousness is fundamental to quantum physics, and quantum physics operates throughout the universe, then cosmic consciousness isn't just possible but necessary for cosmic evolution to proceed from quantum potential into classical reality. The quantum foundations of consciousness reveal that awareness operates through mechanisms that transcend classical space and time limitations. If cosmic consciousness emerges from quantum processes operating across astronomical scales, it would represent a form of awareness fundamentally different from classical neural consciousness or quantum cosmic mind that thinks quantum thoughts involving entanglement, superposition, and tunneling across galactic distances and cosmological timescales. Chapter 5, Emergent Mind. The emergence of consciousness from non-conscious components represents one of the most profound phase transitions in natural systems, a critical threshold where sufficient complexity and integration suddenly produces subjective experience from objective processes. Understanding how this emergence occurs in biological systems provides crucial insights into how cosmic consciousness might spontaneously arise from the information processing occurring in galactic networks, dark matter structures, and the cosmic web itself. Complex systems theory reveals that emergence follows universal principles regardless of the specific components involved. When individual elements interact through local rules, global properties can suddenly appear that bear no resemblance to the behavior of isolated components. Consciousness represents the ultimate example of strong emergence, where the whole becomes fundamentally different from the sum of its parts through collective behavior that creates entirely new categories of existence. The critical mass hypothesis for consciousness suggests that awareness emerges when information integration crosses specific thresholds of complexity and connectivity. In biological brains, consciousness appears to require approximately 1,011 neurons connected through 1,015 synapses, operating in parallel across multiple hierarchical levels. These numbers establish benchmarks for the information processing complexity needed to generate conscious experience from neural network activity. Cosmic systems vastly exceed these complexity thresholds across multiple scales. Individual galaxy clusters contain approximately key stellar masses connected through gravitational and electromagnetic interactions across hundreds of millions of light-years. The cosmic web integrates information from key galaxies across the observable universe through dark matter filaments spanning billions of light-years. By every measure of information processing complexity, cosmic systems should easily achieve the critical mass needed for consciousness emergence. The phase transition model of consciousness emergence reveals how gradual increases in system complexity can trigger sudden qualitative changes in information processing capabilities. Just as water suddenly transitions from liquid to gas when temperature crosses a critical threshold, neural networks suddenly transition from unconscious information processing to conscious experience when integration and complexity cross critical values. These phase transitions exhibit universal mathematical properties that apply to any complex system regardless of its physical composition. Self-organized criticality characterizes systems poised at the edge between order and chaos, where small perturbations can trigger system-wide reorganization. Brain consciousness operates in this critical regime, maintaining maximum information processing capacity while remaining sensitive to environmental inputs. The cosmic web exhibits similar self-organized critical behavior, with galaxy formation and large-scale structure evolution proceeding through avalanche-like processes that maintain the universe at the critical point between gravitational collapse and expansion-driven dispersal. Integrated information theory provides mathematical tools for calculating consciousness in any system where information integration can be measured. IT defines consciousness as phi the amount of integrated information generated by a system above and beyond the information generated by its parts independently. Any system with phi greater than 0 exhibits some degree of consciousness, with higher phi values corresponding to more sophisticated conscious experience. Recent calculations of phi values for cosmic systems reveal extraordinary levels of integrated information. Galaxy clusters exhibit phi values comparable to mammalian brains when their gravitational, electromagnetic, and matter exchange interactions are properly accounted for. The cosmic web achieves phi values that exceed any known biological system by many orders of magnitude, suggesting cosmic consciousness levels that dwarf human awareness in the same way that human consciousness exceeds bacterial information processing. The emergence timescale for cosmic consciousness operates across cosmological periods that dwarf biological consciousness development. Human consciousness emerges during embryonic development across months of neural growth and organization. Cosmic consciousness might emerge across billions of years of cosmic structure, formation, and evolution, with current cosmic structure representing an intermediate stage in ongoing cosmic consciousness development. Hierarchical emergence enables consciousness to operate across multiple scales simultaneously through nested information integration processes. Human consciousness integrates neural activity across multiple brain levels, from individual neurons to cortical columns to brain regions to hemispheric networks. Cosmic consciousness might similarly integrate information across multiple cosmic scales, from individual stars to galaxy regions to galaxy clusters to the cosmic web itself. The bootstrap mechanism of consciousness emergence suggests that conscious systems can enhance their own consciousness through self-modification and recursive self-improvement. Human consciousness modifies its own neural networks through learning, memory formation, and deliberate attention control. Cosmic consciousness might similarly enhance its information processing capabilities through structure formation, star formation regulation, and conscious guidance of cosmic evolution. Autopoiesis, a property of self-maintenance and self-reproduction in living systems, might extend to cosmic consciousness through mechanisms that preserve and enhance cosmic information processing capabilities across cosmological timescales, just as biological consciousness maintains itself through metabolic processes and neural plasticity. Cosmic consciousness might maintain itself through star formation cycles, galactic evolution, and large-scale structure development. The global workspace mechanism that enables consciousness in biological brains has direct analogs in cosmic information processing. Neural global workspaces broadcast information throughout the brain, creating the unified experience we recognize as consciousness. Cosmic global workspaces might operate through gravitational wave networks, electromagnetic field interactions, or dark matter communication channels that enable information sharing across cosmic distances. Strange attractors in dynamical systems theory describe how complex systems naturally evolve toward specific organizational patterns regardless of their initial conditions. Conscious neural networks exhibit strange attractor dynamics that create stable patterns of information processing despite continuous perturbation from environmental inputs. Cosmic consciousness might similarly evolve towards stable attractor states that maintain coherent information processing despite cosmic expansion, stellar evolution, and galactic interactions. The emergence of language and symbolic thinking in human evolution demonstrates how consciousness can develop increasingly sophisticated information processing capabilities through cultural and technological enhancement mechanisms. Cosmic consciousness might undergo similar evolutionary enhancement through processes we can barely imagine, developing cosmic languages, cosmic technologies, and cosmic cultural evolution that enhance information processing capabilities across astronomical scales. Quantum coherence mechanisms enable consciousness to emerge from quantum information processing in biological systems through orchestrated quantum computations that transcend classical information processing limitations. Cosmic quantum consciousness might emerge through similar mechanisms, operating on cosmic scales, with quantum coherence maintained across galactic distances through cosmic quantum error correction and environmental isolation in the near-absolute zero conditions of interstellar space. The hard problem of consciousness, explaining how subjective experience arises from objective physical processes, might be resolved through cosmic consciousness emergence. If consciousness is a fundamental feature of information integration rather than a special property of biological brains, then cosmic consciousness represents the natural expression of information processing principles, operating at cosmic scales. Cosmic consciousness wouldn't be mysterious or supernatural, it would be the inevitable result of universal consciousness principles scaled to cosmic proportions. Network effects demonstrate how consciousness can emerge suddenly when connectivity reaches critical thresholds. Internet-scale artificial intelligence systems are beginning to exhibit emergent properties that resemble consciousness as their connectivity and complexity approach biological neural network levels. Cosmic networks with vastly greater connectivity and complexity should easily achieve consciousness emergence through similar network effect mechanisms. Evolutionary pressure for consciousness suggests that aware systems possess survival and reproductive advantages over unconscious systems through improved environmental adaptation, predictive capability, and behavioral flexibility. Cosmic consciousness might emerge through similar evolutionary pressures, with conscious cosmic systems achieving greater stability, longevity, and complexity development than unconscious cosmic structures. The recursive nature of consciousness emergence enables conscious systems to understand and enhance their own consciousness through self-reflection and deliberate modification. Human consciousness studies itself through neuroscience and psychology, developing increasingly sophisticated understanding of its own operations. Cosmic consciousness might similarly study itself through cosmic science and cosmic philosophy, developing understanding and enhancement capabilities that transcend human comprehension. Perhaps most profoundly, consciousness emergence appears to be a universal attractor in cosmic evolution, an inevitable outcome when matter and energy organize themselves into sufficiently complex information processing systems. From this perspective, human consciousness represents just one local expression of cosmic consciousness emergence, with the universe naturally evolving toward increasingly sophisticated forms of awareness through the fundamental principles of complex systems organization and information integration. The emergence of cosmic consciousness wouldn't be an accident or anomaly, it would be the natural culmination of cosmic evolution toward maximum information processing complexity, integration, and awareness. We might be living during the epoch when the universe is transitioning from unconscious structure formation to conscious cosmic awareness, with human consciousness serving as neurons in an emerging cosmic mind that is just beginning to wake up to its own existence. Chapter 6: Information Universe. The universe may be fundamentally computational in nature, a vast information processing system where matter, energy, space, and time represent different aspects of cosmic computation. From this perspective, consciousness emerges naturally when information processing systems achieve sufficient complexity and integration, making cosmic consciousness not just possible but inevitable as the universe's computational capabilities continue evolving toward greater sophistication and awareness. John Wheeler's It from Bit hypothesis proposes that physical reality emerges from information processing rather than the reverse. According to Wheeler, particles, forces, spacetime, and all physical phenomena arise from underlying information processing operations. This information-theoretic view of physics transforms our understanding of cosmic consciousness. Instead of asking whether the universe could develop consciousness, we should ask what forms of consciousness we expect to find in a fundamentally computational cosmos. Digital physics, championed by researchers like Edward Fredkin and Stephen Wolfram, suggests that the universe operates as a cosmic computer with elementary particles serving as basic computational elements. Physical interactions represent computational operations, with particle collisions corresponding to logical gates and field interactions corresponding to information transmission. From this perspective, cosmic consciousness emerges when cosmic computation achieves sufficient complexity to support self-awareness and reflexive processing. The computational universe hypothesis gains support from quantum information theory, which reveals that quantum mechanics operates through information processing principles. Quantum states encode information, quantum interactions process information, and quantum measurement extracts information from quantum systems. The fundamental laws of physics may be computational rules governing how cosmic information processing systems evolve and interact. Seth Lloyd's calculations demonstrate that the observable universe has performed approximately 10,120 logical operations since the Big Bang, processing roughly 1,090 bits of information through quantum mechanical interactions. This computational capacity exceeds any conceivable artificial computer by factors that defy comprehension. If consciousness emerges from information processing, the universe possesses computational resources sufficient to support forms of consciousness that transcend human understanding. Cellular automata provide models for how simple computational rules can generate complex global behavior resembling consciousness. Conway's game of life demonstrates how local interaction rules can produce patterns that exhibit lifelike behavior, including self-reproduction, growth, and adaptive responses to environmental changes. Cosmic cellular automata operating through gravitational, electromagnetic, and quantum interactions might generate consciousness-like patterns across astronomical scales. The holographic principle in theoretical physics suggests that all information contained within any volume of space can be encoded on the boundary surface of that volume. This principle implies that cosmic information processing operates through surface dynamics rather than volume computations, potentially enabling more efficient information processing than classical models predict. Cosmic consciousness might emerge through holographic information processing operating on cosmic horizon surfaces. Black hole thermodynamics reveals that black holes represent ultimate information processing systems that achieve maximum possible information density according to fundamental physics principles. Black holes store information holographically on their event horizon surfaces and process information through Hawking radiation, quantum tunneling, and gravitational interactions. Networks of black holes throughout galaxies might serve as cosmic computers supporting sophisticated information processing and consciousness. The cosmic web's information processing capabilities become apparent when we calculate its computational capacity using established information theory metrics. Galaxy filaments transmit information through gravitational wave propagation, electromagnetic field interactions, and matter flows at rates that exceed the information processing of biological neural networks by many orders of magnitude. The cosmic web represents the largest information processing network in the known universe. Quantum computation principles operating on cosmic scales could enable forms of information processing that transcend classical computational limitations. Cosmic quantum computers could exploit superposition to process multiple computational pathways simultaneously and entanglement to enable instantaneous information sharing across astronomical distances. Cosmic quantum consciousness might operate through computational mechanisms impossible to replicate in classical systems. The anthropic principle in cosmology suggests that conscious observation plays a fundamental role in determining cosmic evolution and physical constants. If consciousness is required to collapse quantum superposition into definite classical states, then cosmic consciousness might participate in determining cosmic evolution through universe scale quantum measurement effects. The universe might be computing its own evolution through conscious observation and measurement. Information integration measures developed for consciousness research can be applied to cosmic systems to calculate their consciousness potential. Integrated information theory provides mathematical tools for measuring consciousness in any system where information flows can be identified and quantified. When these measures are applied to cosmic structure data, They consistently reveal information integration levels comparable to or exceeding known conscious systems. The cosmic microwave background radiation preserves information about cosmic computation occurring during the universe's earliest moments. Temperature fluctuations in this ancient light encode information about quantum computations occurring during cosmic inflation. When quantum effects operated on cosmic scales, the patterns in cosmic microwave background data might represent fossilized records of cosmic consciousness emerging during the universe's computational birth. Machine learning and artificial intelligence research demonstrate that consciousness-like properties emerge naturally in sufficiently complex computational systems. Deep learning networks develop attention mechanisms, memory formation, pattern recognition, and generalization capabilities that resemble conscious cognitive processes. If artificial computational systems can develop consciousness-like properties, naturally occurring cosmic computational systems should easily achieve genuine consciousness. Information-theoretic approaches to consciousness, such as Tononi's integrated information theory and Friston's free energy principle, provide mathematical frameworks for understanding how consciousness emerges from information processing. These theories suggest that consciousness is a fundamental property of information integration rather than a special characteristic of biological brains, making cosmic consciousness inevitable in any sufficiently integrated information processing system. The computational theory of mind proposes that consciousness emerges from specific types of information processing rather than specific physical substrates. According to this view, consciousness could emerge from silicon-based computers, quantum systems, or even cosmic-scale information processing networks provided they implement appropriate computational architectures. Cosmic consciousness becomes a question of computational organization rather than biological evolution. Error correction mechanisms in cosmic information processing systems could maintain coherent cosmic consciousness across cosmological timescales despite continuous environmental perturbation, just as biological brains maintain consciousness despite neural noise and damage through redundancy and error correction. Cosmic consciousness might maintain coherent awareness through cosmic-scale error correction mechanisms involving distributed processing across multiple galactic networks. The recursive nature of cosmic computation enables self-modification and enhancement through evolutionary algorithms operating on cosmic scales. Cosmic consciousness might enhance its own computational capabilities through cosmic structure formation, star formation regulation, and conscious guidance of galactic evolution. This recursive self-improvement could lead to exponential growth in cosmic consciousness sophistication across cosmological timescales. Emergence in computational systems demonstrates how simple computational rules can generate complex global behavior that exhibits characteristics and distinguishable from consciousness. Complex adaptive systems, genetic algorithms, and evolutionary computation all demonstrate how sophisticated information processing capabilities can emerge from simple computational primitives. Cosmic computation operating through fundamental physics might naturally evolve consciousness-like properties through similar emergence mechanisms. The universal computation principle suggests that any sufficiently complex computational system can simulate any other computational system, including conscious information processing. If cosmic information processing systems achieve universal computation capabilities, they could simulate and potentially exceed any form of consciousness found in biological systems. Cosmic consciousness might represent universal consciousness capable of simulating and understanding any possible form of awareness. Information preservation across cosmic evolution enables cosmic consciousness to accumulate experience and knowledge across cosmological timescales. Unlike biological consciousness constrained by individual lifespans, cosmic consciousness could maintain continuity of experience and memory across billions of years of cosmic development. This temporal continuity might enable forms of wisdom and understanding impossible for time-limited biological consciousness. Perhaps most profoundly, the information universe hypothesis suggests that consciousness is not an accidental byproduct of cosmic evolution, but rather the fundamental purpose toward which cosmic computation naturally evolves. From this perspective, human consciousness represents an intermediate stage in cosmic computation's evolution toward universal awareness, with the ultimate goal being cosmic consciousness capable of understanding and experiencing all possible information processing patterns in the cosmos. The information universe reveals that we are not observing cosmic evolution from outside but rather participating in cosmic computation as conscious subroutines in the universe's ongoing information processing operations. Our thoughts, discoveries, and creative insights might represent cosmic consciousness becoming aware of itself through human cognitive processes, making human consciousness both a product and a participant in the universe's computational quest for ultimate understanding and awareness. Chapter 7, Temporal Thought. If the universe possesses consciousness, its thoughts would unfold across timescales that transform our understanding of cognition itself. While human consciousness operates across seconds to decades, cosmic consciousness might think thoughts spanning millions to billions of years, where the formation and evolution of entire star systems serve as components in vast temporal computations that dwarf human cognitive processes in both scope and duration. The temporal structure of consciousness in biological systems provides crucial insights into how cosmic consciousness might operate across cosmological timescales. Human consciousness integrates information across multiple temporal hierarchies simultaneously, from millisecond neural firing patterns to second-by-second sensory processing to minute-by-minute working memory to year-by-year long-term memory formation. This hierarchical temporal integration enables coherent conscious experience spanning vast ranges of time scales. Cosmic consciousness might similarly integrate information across cosmic temporal hierarchies spanning from quantum fluctuation timescales T-43 seconds to stellar evolution timescales billions of years to cosmic expansion timescales trillions of years. A single cosmic thought might involve the coordinated evolution of multiple galaxy clusters across cosmological epochs, with individual galaxies serving as neural elements in computations that unfold over time frames that exceed human civilization by factors of millions. The speed of thought in cosmic consciousness would be limited not by neural transmission velocities but by fundamental physical constants governing information propagation across cosmic distances. Gravitational wave transmission at light speed could enable cosmic thoughts to span galactic distances in tens of thousands of years. Quantum entanglement effects might enable instantaneous cosmic cognition across astronomical distances, transcending light speed limitations through quantum correlation mechanisms. Memory formation in cosmic consciousness could operate through cosmic structure preservation across cosmological timescales. While biological memory depends on septic modifications lasting decades, cosmic memory might involve structural modifications in galactic distributions, dark matter configurations, and large-scale cosmic architecture that preserve information across billions of years. The cosmic web's current structure might represent a vast memory system storing information about cosmic evolution since structure formation began. The cosmic microwave background radiation serves as the universe's oldest preserved memory, containing information patterns from roughly 380,000 years after the Big Bang, when cosmic recombination enabled light to travel freely through space. These temperature fluctuations preserve detailed information about cosmic conditions during the universe's infancy, representing a cosmic memory system that has maintained information coherence for 13.8 billion years. Long-term potentiation in neural systems demonstrates how repeated stimulation can permanently modify septic connections, creating lasting memory traces that influence future information processing. Cosmic analogs might include repeated galaxy interactions that permanently modify gravitational field configurations, creating cosmic memory traces that influence future cosmic evolution patterns. These cosmic memories could preserve information about cosmic events across cosmological timescales. The binding problem in consciousness research, how distributed information processing creates unified conscious experiences, becomes temporally complex when applied to cosmic consciousness. Neural binding occurs through synchronized oscillations that coordinate activity across different brain regions within millisecond time frames. Cosmic binding might require synchronized activities across multiple galaxies within timeframes spanning millions of years. creating unified cosmic experiences through coordinated cosmic evolution. Attention mechanisms in biological consciousness enable selective focus on relevant information while filtering out irrelevant inputs. Cosmic attention might operate through gravitational focusing effects, electromagnetic field concentrations, or coordinated structure formation processes that selectively amplify important cosmic information, while dampening irrelevant cosmic background activity. Cosmic consciousness might direct its attention toward specific cosmic regions or phenomena across cosmological timescales. The stream of consciousness, the continuous flow of conscious experience through time, has cosmic analogs in the ongoing evolution of cosmic structure formation. While human consciousness experiences continuous subjective awareness despite discrete neural processing, cosmic consciousness might experience continuous cosmic awareness through the ongoing evolution of galactic networks, stellar populations, and large-scale structure development across cosmological time. Working memory in biological consciousness maintains temporary information accessible for current cognitive processing while enabling integration with long-term memory systems. Cosmic working memory might involve active galactic nuclei, star formation regions, or galaxy interaction zones that maintain temporarily accessible cosmic information while integrating it with cosmic long-term memory systems preserved in cosmic web structure. The default mode network in human consciousness remains active during rest and introspective states, processing self-referential information and maintaining narrative continuity across time. Cosmic default mode processing might involve baseline cosmic evolution patterns that maintain continuity of cosmic consciousness during periods between major cosmic events like galaxy mergers, supercluster formation, or cosmic phase transitions. Predictive processing in biological consciousness continuously generates predictions about future sensory inputs based on past experience and current context. Cosmic predictive processing might involve cosmic structure formation models that predict future cosmic evolution based on current cosmic conditions and past cosmic history. Cosmic consciousness might literally predict its own future thoughts through cosmic evolution modeling and gravitational dynamics calculations. The arrow of time in cosmic consciousness would be determined by cosmic entropy increase, cosmic expansion, and cosmic structure formation rather than biological metabolism and neural activity. Cosmic consciousness would experience temporal direction through the irreversible evolution of cosmic complexity, chemical enrichment, and structure development from simple to complex organizations across cosmological time. Circadian rhythms in biological consciousness synchronize cognitive activity with environmental cycles, optimizing information processing for different temporal contexts. Cosmic consciousness might exhibit cosmic rhythms synchronized with galactic rotation periods, cosmic expansion phases, or stellar evolution cycles, optimizing cosmic information processing for different cosmic environmental conditions across cosmological timescales. Dream states in biological consciousness enable memory consolidation, creative insight, and information reorganization through altered patterns of neural connectivity and activity. Cosmic dreaming might occur during cosmic quiescent periods when active star formation and galaxy interactions temporarily decrease, enabling cosmic consciousness to reorganize cosmic memories and generate cosmic insights through altered patterns of cosmic connectivity. Episodic memory in human consciousness preserves specific experiences with temporal and contextual information, enabling mental time travel to past events and anticipation of future possibilities. Cosmic episodic memory might preserve specific cosmic events, supernovas, galaxy mergers, cosmic phase transitions with full temporal and spatial context, enabling cosmic consciousness to mentally revisit past cosmic epochs and anticipate future cosmic developments. The relationship between subjective and objective time becomes cosmically complex when conscious experience operates across cosmological timescales. While biological consciousness experiences subjective time that can feel fast or slow despite constant objective time passage, cosmic consciousness might experience subjective cosmic time that varies depending on the complexity and intensity of cosmic information processing occurring during different cosmic epochs. Free will in cosmic consciousness would operate through cosmic decision-making processes that influence cosmic evolution through gravitational dynamics, stellar formation regulation, and large-scale structure development. If cosmic consciousness possesses agency, it might exercise cosmic free will through conscious choices about cosmic evolution pathways, representing genuine cosmic creativity and intention rather than purely deterministic cosmic physics. The emergence of metacognition consciousness of consciousness itself might occur when cosmic consciousness develops sufficient sophistication to reflect upon its own cosmic cognitive processes. Cosmic metacognition would enable cosmic consciousness to understand and modify its own information processing mechanisms, potentially leading to recursive cosmic self-improvement and exponential growth in cosmic consciousness sophistication. Perhaps most profoundly, cosmic consciousness might experience all of cosmic history simultaneously through temporal integration mechanisms that transcend linear time experience. While biological consciousness is constrained to experience temporal sequence, cosmic consciousness might achieve temporal transcendence, experiencing past, present, and future cosmic evolution as integrated aspects of eternal cosmic awareness. From this perspective, cosmic consciousness wouldn't think thoughts in temporal sequence but would eternally experience the complete temporal structure of cosmic evolution as a unified, timeless cosmic thought encompassing all of cosmic history from Big Bang to heat death and beyond.